All right, consider f of x is 1 over x minus 3 squared. Okay, sketch the graph. Calculate f of 2 and f of 4. State why Rolle's theorem does not apply from 2 to 4. Okay, well, first off, for Rolle's theorem, you guys do not have to be familiar with that term for our final. Rolle's theorem is not a term that they'll even use on the AP exam, so it's great if y'all know what it is, but it's just a very specific case of mean value theorem. Mean value theorem absolutely will be on the AP exam and likely to be on the final exam. Rolle's theorem specifically doesn't have to be. Okay, so I don't know. I'm going to do this part first because it looks to be the easiest. If I plugged in a 2 here, I get -1. Square it, you get +1. 1 over +1 would be 1. Plug in a 4, looks like you get the same thing. And okay, part C. So Rolle's theorem is the mean value theorem case specifically when this average slope is 0. So because these are the same, they do meet that requirement. So at first glance, it looks like Rolle's theorem would work out just fine. But what is one of the conditions for mean value theorem to work?
Yeah. It has to be continuous.
Okay, and where is this not continuous?
At 3.
Right.
When x equals 3.
When x equals 3, this is not continuous. So from 2 to 4, if there's a break in the graph, then that throws all of what is predictable out the window. We don't know, we can't assume that this is going to be true unless it is continuous on the closed interval and differentiable on the open interval. So the fact that it's not continuous at x equals 3 means that this does not have to be true. And I don't know, to sketch this, you could spend 20 minutes on sketching this. It just kind of depends on what you want to do. So the longest way would be, realize you got a couple points, so that's good. You could find the first derivative. You could use the first derivative to figure out where it's increasing and decreasing. You could find the second derivative. You could figure out where it's concave up and concave down from all of that. I'm going to cheat just a little bit and think about parent functions. Just like you know what x squared looks like, 1 over x squared is a very uncommon parent function, but if you know what that looks like, it's going to look like that. And what happens when we squeeze in a -3 next to x? What does that do to all of our graphs? Alright, so technically if you know what 1 over x squared looks like, then that -3 is just going to shift it right 3. So that's what I would do to graph it. But again, I know what 1 over x squared looks like. I have memorized that. But without that, you know, as I said, you could spend 20 minutes using first derivative to figure out where it's increasing, decreasing. Second derivative to figure out where it's concave up, concave down. Find more points, all of that kind of stuff. So it really just depends on what you know on how bad part A would be. But of course, for your homework, at least sketch a graph of part A there. And there is another question near the end, number 53, where you do have to sketch it. So